All right, class. Now, we went over what sets and subsets were, and you worked on some real life examples of your own. But now we're going to take that into the content of math. Okay. Now, what we do is there are certain names that numbers have, and we categorize them in what's called the real number system. And so I'm going to show you a little bit about how that sets and subsets works in this scenario. And so, because that's how numbers are categorized. And so, for our first subset, we're going to start with the smallest and work our way out. For our first subset, we have what are called natural natural numbers, and these are numbers that you naturally start counting with. So, if I were to say stop, I want you to start counting now. You will probably start counting with the number one, and then two, and then three, four, five. So these are numbers that you naturally start counting with. And so you have one, two, three, four, five, six, and I can keep on going forever. So I can even say the number 3,124 is also a natural number. These are numbers that are positive. They don't have any decimals, uh, and they don't have any decimals, and they're positive. That's it. These are also called counting numbers. So if you can see it in either one of those, called either one of those, natural or counting numbers. Then we have something else. Actually, let me go back. Then we have something else. It's basically counting now. We have something called whole numbers. So whole numbers include counting numbers, right? You see how counting numbers are in the whole numbers basket. Uh, but there's one thing that is not a natural number, but is a whole number, and that is zero. So the only difference between natural numbers and whole numbers, natural counting numbers and whole numbers, is zero. Okay. Then we have something goes out a little bit further. Excuse my drawing. I'm using a drawing tablet, and I'm still getting used to it. The next one is called integers. Integers. So these are the natural numbers and its opposites, basically. So we can have -1, -2, -3, -4. Okay. So -1, -2, and so on and so forth. Even -3,124 would be an integer. So you see here that not all integers are whole and natural, because we have some of these. These are integers. But all these natural numbers and whole numbers are integers. So integers include the negatives and the positives and zero. Okay, you see how all of these are within the integers box. Okay, and then we're going to go with the last thing. Okay, and these are called rational numbers. Okay, rational numbers. Now, rational numbers are everything that's kind of not whole, like your two or your -2. Those are whole numbers, meaning they don't have decimals to it. Okay, so anything with a decimal is really just going to be in the natural numbers. It's just going to be only a natural number, and so we have like 4.25. Now, this is a rational number because it has a decimal, and it's also called a terminating decimal. Terminating decimal. Now, the reason why it's terminating is because it only has two numbers after the decimal. It only has two numbers after the decimal. That is 2 and a 5, and it stops. Okay? It just stops. But there are other ones that are called that have decimals, and they're called something a little bit different. And it's kind of easy to remember. So when I divide 1 and 3, I get 0.33 repeating. You probably have heard of these repeating. These type of numbers right here, where it has this sign over here, that just means it repeats forever. So it's 3 on and on and on forever. And so these are called repeating decimals. Repeating decimals. Okay. Uh, and they just go on and on forever. So you can have 1.33 repeating forever. You can have a lot of different types of repeating decimals. But when you start dividing something and you're getting a repeating sequence. So it could be just one number repeating, or it could be like a 4.252, well, 4.265265, and it just keeps repeating. You could just put a line over that beginning 265, and you'll be good there. And so that indicates that 265, that sequence of 265 repeats forever and ever and ever. Now you also have fractions in this, but I want you to be careful with the fractions, because fractions can be simplified, as you know. So let's say 1/3, which is that 0.33 repeating, that's going to be in this case. Okay, these are related. Let's say 4/3, or 1 1/2, which is 1.5, and this is 1.33, right? So these are all just rational numbers. But if I have something like, uh, let's say, -2 over, oh, excuse me, I have a little bit of technical difficulties here. Okay, let me go back. Okay, -2 over -2. Well, that simplified. I mean, 2 over 2 is 1. And so this is really -1. Let's say I have, let's say I have a number which is, go over here. Let's say I have a number which is 4 over 2. Well, 4 divided by 2 is just 2. So that would really go right here. So even though it's a fraction, it can be simplified. Let's do another one. It can't be simplified, so it goes to a natural number. Let's do another one, which is 100 divided by 10. Well, let me take these out, these zeros, because that would just cross out. And so we have 10 over 1, which is really just 10. Anything over 1 is itself. So 10. So 10 would be a, what do y'all think? It would be a counting number. A counting number. And so, but if it had -10 over 1, or -100 over 10, that would be a -10. And then that would not go in natural or whole numbers. It would be then considered an integer. Okay? So let's go over a couple of examples, because this is everything you need to know. This is kind of like your cheat sheet. So I'm going to go over a couple of examples. I'm going to go ahead and erase this. And let's say my first example is, let's say -2. Well, that would be considered an integer. And since it's considered an integer, this integer box is also within the rational numbers box, so it would also be considered a rational number. Now let's try the number 1. The number 1 is a natural number. A natural number. It's also, if it's a natural number, it's also a whole number. And if it's a whole number, it's also a integer. And if it's an integer, it's also a rational number. Okay. Let's say the number, But this, if you were putting it on a visual representation like this, you would put it in the natural numbers box, because when you put it in this box, you're saying it is all of these. Okay, let's say I have negative 6 over 2. Now I'm going to give you a little bit of time to try to work that out on your own. What is negative 6 over 2? Well, negative 6. Well, 6 divided by 2 is how many 2's can fit in the 6? Well, that's 3 of them. And since there is a negative there, it is a negative number. So that's a negative 3. So this is actually negative 3. Negative 3 goes in the what box? If I were to put it over here in this representation, over here, where would it go? Well, I would actually put it over here, if you can see me, where I'm clicking here. So that is in the integer box. Now, if it is an integer, it's also a rational number. But if it's an integer, that doesn't make it a whole number or a natural number. You see, these are separate. Okay. Let's do an easy one. 4.6 repeating. This has a decimal in it, and a decimal just makes it a rational number. Maybe say 3.14. This is actually a repeating decimal. So this one is not repeating. It is actually a terminating decimal. And terminating decimals just go in rational numbers. All decimals go in rational numbers. Now let's look up the last one. So I'm going to say 1/4. Now, what is 1/4? Can that be simplified? I don't know. Let me say top inside the house, bottom outside the house. Nothing goes into 1. 4 doesn't go into 1 any times. So what I need to do is add my decimals and add a 0. So now does 4 go into 10? Yes, it does. It goes into 10 2 times. And that's when I subtract these, I get 8. All right. Oh, wait. 2 times. Wait. 2 times, that makes it 8. Excuse me, I actually did this wrong. And so that's going to make this a 2. Look at me messing up, the math teacher. All right, then I'm going to add a 0, bring it down. Now I'm looking at 20. Well, we know 4 goes into 20 5 times, and that's going to equal 20. So that's going to be a 0. So now we're going to stop there. Don't have to add any more zeros. So this is actually 0.25. It stops. And so that is actually a rational number. Okay, let me know if you have any questions on that. If you need any more examples, of course, we're going to go through some activities. You can always reference this back. And I'm actually going to have it as one of the images for you to reference back when you're doing your activity in Nearpod. All right, have a great day.